Hello students, welcome to Dr. Shourab's classes. We are solving in this video this questions from UPSC 2021 paper, and this is from the mathematical optional, maths optional paper, and this is paper 1. So in the previous video I've seen that we have solved the question 2a, so it's question number 2b. So let's solve this. So it's given that f of xy is equal to mod of x square minus y square. So we have to find f of xy at 0 0 and f of yx at 0 0, and we have to show that f of xy at 0 comma 0 is equal to this f of yx at 0 comma 0, right? So how we will do this? So we have f of fx0 at 0 0 is equal to, so limit h tends to 0, f of h comma 0 minus f of 0 comma 0, right, divided by h. So we have limit h tends to 0, so mod of h square by h. So if we take the square out of the mod, so it have mod of h whole square by h, which is nothing but 0, right? Similarly, if we find f of, okay, let's do here, so f of y at 0 comma 0, so we have this limit k tends to 0, f of 0 comma k minus f 0 comma 0 by k, right? So here it will be limit k tends to 0 minus of k square by k. So since it is mod, we can write this limit k tends to 0, this mod of k whole square by k. So simply it is equal to 0. Now we have to find this value of particularly this f of xy and f of yx at 0 comma 0, right? So now this f of xy at 0 comma 0, it is equal to, we can write it as limit h tends to 0, f of y h comma 0 minus fy 0 comma 0 by h, right? So let us take this as equation 1. Okay, so we are just trying to make it simplify as it is possible, right? So now we have to find the, since we have find the f of y at 0 comma 0 is equal to this, already it is 0, right? So what we have to do, we have to find f of y at h 0. So we have to find the value of this. So it is nothing but limit k tends to 0, f of h comma k minus f of h comma 0 by this k. So from here we can write this limit k tends to infinity, so this limit k tends to 0, right? So it will be mod of h square minus k square minus of mod of h square by k, right? So here you can write this limit k tends to 0, right? This is h square minus k square mod. So I am taking the square out of the mod, so this is mod of h whole square by k. So we can write this in this manner that, so this is limit k tends to 0 if h square is greater than k square. If, then we can write this h square minus k square, and simply it is minus of h square by k. So from here you write this limit of k tends to 0, this minus k square by k, which is nothing but 0. So again what I found that, so this is nothing but limit h tends to 0, 0 minus 0 by h, which is nothing but 0. So this is, we have proved this f of x comma y, this f of xy at 0 comma 0, right? Now the next is we have to find this f of yx at 0 comma 0. So it is given as limit k tends to 0. So we can do this f of x 0 comma k minus f of x 0 comma 0 by k. So let us take this as equation 2. Okay, so we have already this f of x comma 0 comma 0, this is equal to, so this is already equal to 0, right? So we have to find the limit, so this f of x at 0 comma k. So I have to find this value, so it is nothing but the limit h tends to 0, f of h comma k minus f of 0 comma k by h. So we can write it simply as it's so it is h square minus k square in mod, and this is minus of k square within mod by h. So what we can do, we can write this simply as limit h tends to 0, right? So we can simply this mod of h square minus k square minus of k square, right, by h. Now if the thing is that h square is less than k square, so what we will write, so we will write limit h tends to 0 minus of h square minus k square minus k square by h, right? So from here we can find this limit h tends to 0 minus of h square by h equal to 0. So this is also from 2 we can find that, so this is limit k tends to 0, 0 minus 0 by a 0 minus 0 by h, so this is equal to k, so this is equal to 0. So from here you can find that both the equation, this 1 and 2, is equal to 0, right? So f of xy 0 comma 0 is equal to 0, f of yx 0 comma 0 equal to 0, and we have given that we have to prove this both are equal. So this is equal to f of yx 0 comma 0, right? So hence proved. So this goes for this equation, question number 2a, 2b. Okay. So in the next video we will see question number 2c, the third part of the question 2.